Oh man, now we're on to example 3, and we're still using our Isosceles Triangle theorem, which states in Isosceles Triangle, the base angles are congruent, which remember, those are the angles that are crossed from your two congruent sides. Okay, so looking at this picture, eventually I want to find angle A. But currently, I don't know what it is. Nothing's there. So I have to use other information in the picture to help me get to angle A. So, looky here. I have an isosceles triangle because two of my sides are congruent. Yay! Which means that the base angles are congruent. And remember, you guys, the base angles are the angles across from the congruent sides. Okay, so here's a congruent side, so the angle across from it is one of my base angles, so it's congruent to the other one. This is another congruent side, which means the angle across from it is also going to be congruent. Okay, so that's 6y plus 1. That means that this angle also has to be 6y plus 1. Oh man. So now that I know my base angles are congruent, I now know what all three angles are in my triangle. Which, guess what, you guys? The way that we find all of the degrees of a triangle using the triangle angle sum theorem, all three angles in a triangle add up to be 180. So if I add angle A to angle B to angle C, bam, I know it should equal 180. So let's solve this thing and figure out what angle A is. Okay, so I currently know that the measure of angle A plus the measure of angle B plus the measure of angle C should all add up to be 180. Okay, so I'm going to substitute these bad boys in where they go. So the measure of angle A is 6y plus 1. The measure of angle B is also 6y plus 1. Holy hot dog, because they're congruent, because they're base angles. And the measure of angle C, our vertex angle, is 21y plus 13. And all three of those should add up to be 180. Okay, so I'm going to be solving for y first, and once I know y, I should be able to find the measure of angle A. So let's start by combining our like terms. Let's go. So I'm going to start by combining all my y terms. So there's a y, there's a y, and there's a y. So let me add those together. So 6y plus 6y is 12y, and 12y plus 21y gives me 33y. So 33y, and now let me add the terms together that don't have y. So I have a 1, a 1, and a 13. So 1 plus 1 gives me 2, and 2 plus 13 gives me 15. Holy hot dog, right? Alright, let's start solving this thing for y. So the way that I'm going to bring my 15 to the other side, since it's a positive 15, I'm going to subtract this thing on both sides. And 15 minus 15 cancels out and turns to 0. 180 minus 15 will give me 165 degrees. So now I'm left with 33y equals 165 degrees. Alright, so from here, I need to solve this thing for y, which let's see here. Alright, the 33 is secretly multiplying to the y, so the way I'm going to bring that bad boy to the other side is, since it's multiplying, I'm going to divide both sides by 33. Alright, which 33 divided by 33 cancels, and 165 divided by 33, let's see. I'm pretty sure that's 5, but I'm going to double check. I'm going to do some side work. So 33 times 5, I think, gives me 165. Let's see. Holy hot dog, it does. So it is 5. So my y is going to equal 5. But guess what, you guys? I'm not done. The problem doesn't say find y. It says find the measure of angle A. Okay, so I know the measure of angle A is 6y plus 1, so I can use my y to help me find the measure of angle A. And I'm going to solve for that over here since I'm running out of space over here. Okay, so the measure of angle A equals 6y plus 1, which I know what y is. Y is 5. So I'm going to replace this y with a 5, and then I should be able to find angle A. So let's see here. The measure of angle A equals 6 times my y, which is a 5, plus 1. And 6 times 5 is 30. And 30 plus 1 gives me 31 degrees. So the measure of angle A is 31 degrees. Wasn't that just It was just so amazing, you guys. The measure of angle A is 31 degrees. Didn't that just make your entire life solving that problem? I agree. That was so much fun. So using the isosceles triangle theorems, knowing that our base angles are congruent, we were able to tackle this epic problem. Holy hot dog.